you, Justin, and thank you for having me up for the forum tonight. It's great to be able to implement and do these things, but also present on them and talk about what we've been doing, what automation we've been doing. So tonight I'll be talking about smart robotics for semi-automated pruning. But firstly, just a little bit about myself. So my PhD is in field robotics. I build robots that go out in the field and actually do something. Before that, I did an undergrad in computer science and electronic engineering, and I've been teaching at Trobe since 2008, mostly in areas of robotics and electronics, programming, a whole bunch of different areas. But one thing I've been doing is developing escape rooms, because not to stop my students escaping, but to try and make learning a bit more fun and engaging, and that's something that's been a lot of fun to actually do and partner with them. Some past robots that I've been building. Here's a few pictures of some of them. One of them down the bottom is Wombat. That's a little robot to go through wombat burrows. It accidentally went viral a few years ago and got 4 million views on YouTube or something like that. Completely surprised everyone, including us. We've got a new version of that where we're calling it Armorbot, and it's being used in South America to go through armadillo burrows, which is also a bit of fun. So the problem that we were trying to address to begin with, and I'll have a timeline in a moment, was this problem here. The winter pruning, very time consuming, takes a long time, and very high labour costs to actually achieve this. And the labour shortages make that even harder to do at times. Doing this with the manual method with secateurs, electric secateurs, also leads to some injuries that happen from time to time. And I've met a few people who have had the injuries as well. And when you apply this not on just a small block but over a very large area, this becomes very expensive to do each and every year. And so this was something that was pitched to Emmerich a long time ago in 2019 of, well, what can we do about this? And it was talked about then, well, maybe there's some sort of automation approach that we can take to this. If we can apply automation to this, maybe we can save people money, make things happen faster, make it happen more efficiently, and avoid some of those labour shortages that all the COVID things exacerbated even further. So we had a field trip in 2019 where a number of you met with me, and I was taken out and shown and got to sample some of the produce as well, which was delicious. But then it came about 12 months before we actually had any funding for it. So Innovation Connections provide match funding for DFA to actually make this project happen. And then we had 3 rounds of prototypes, and there's been ongoing prototypes since then, and Stephen's been working on some of those. And in 2024, we had a paper accepted into one of the most prestigious field robotics journals around. And so we'll be talking about that in a moment, and what that's actually led to. But firstly, there's some technical challenges when you're doing something like this. And technical challenges include things like, well, how do we actually mechanically prune something? Just because we've done it with secateurs doesn't mean a robot needs to do it with secateurs. Just like how we wash our dishes with a scrubber and things like that doesn't mean we need a robot to wash our dishes the same way, like a dishwasher does. Or a vacuum cleaner that we push like this, it doesn't mean we need to develop a robot to push a vacuum cleaner. And so we've been looking at ways, okay, well, how do we actually do it? We don't need to copy that manual method. We've also got questions about, well, where do we actually prune? And what do we actually not want to prune? There are a couple of things that we didn't want to prune that got pruned at various times, like some posts and things like that. But those things are considerations that we need to take into account. Things like the trellises and the wire and the posts. And then a whole bunch of other ones related to safety and vibration and robustness. After all, we want this to work and not break down every 5 minutes. We want it to keep on going and to be working for people that aren't engineers and don't have an intimate background in the workings of these sort of things and be able to fix them themselves. This gives you a bit of a breakdown of the system as a whole. At the top we have a 3D LiDAR. LiDAR is a bit different to a camera. A camera gives us various colours across a grid. The LiDAR gives us distances. So it tells us in a grid how far away everything is from us. One of the nice things about the LiDAR is we can exclude the ground. And the ground's often a similar colour to our cordon and various other things. So we can exclude the ground, we can exclude anything that's really close to the LiDAR as well. We pass that into a vision system, Raspberry Pi. That's what we've got our cordon detection algorithm. We'll talk about those algorithms in a moment. We do some velocity estimation there, because if we're driving faster or if we're driving slower, that will mean we need to change how our algorithm works. If we're going at double the speed, we'll need to move our head faster because we've got a distance between our LiDAR and our actual cutting head. We have a linear actuator system there. It connects to a 4-bar mechanism which drives our hydraulic cutting bar, so we move that in and out. And then inside our cabin, we've got some fine tuning that we can do based on the amount of foliage and things that we're getting on our plants. There's a bit of a view that's straight from the paper about some of the key components. You see the GPS there, user interface, 4-bar mechanism that's driving the whole system in and out, and our cutting head there with the LiDAR above. Now, if you ever wanted to see the world through the lens of a LiDAR, this is what it looks like, a 3D LiDAR at least. You see there's some segments there. Those segments are a couple of hundred pixels by about 50 pixels, and they're distance ones. So the different colours there are basically different distances. So what we do is first exclude anything that's a long way away, so anything that's outside the range, mostly the ground, or anything that's too close. Maybe there's some leaves sticking up higher that we just want to exclude from the system and not include. We then calculate for each column that's happening there, minimums, maximums, averages, and medians. And then there's an algorithm that goes through, it's detailed in the paper, I won't go through it in detail here, goes through excluding various parts, looking at, okay, well, because you see some of those have kind of bent over in various directions. And so we say, well, that's not the maximum point, the maximum or the minimum point's further back. Because what we want in that A figure there, we want to cut within that band of the purple there. So we're cutting away things, cutting away various things until we can get close enough to that ideal cut region. Now, it's difficult to perfectly cut within that region. A lot of you know that these cordons aren't exactly perfectly straight, they're moving all around, and I'll show you a picture in a moment of how much they're moving all around according to our algorithms. Here's our mounted on a tractor, and here you see what I call the Gillette control. It gives us the depth of cut control. Particularly when we've got lots of foliage, we need to cut a little bit closer than our algorithm thinks is necessary. When we've got less foliage, we can back that off a little bit. And our next one, we've got a couple of videos of the cutter in action, which Stephen's taken recently and provided to us. So there you see the head turning really quickly. It's acting a bit like a router, rotating around. You see at the very top, there's a bar that sticks out and a little black box there. That's the LiDAR, and that LiDAR is looking down on the cordon. It's about 30 centimetres ahead of the cutting head, and so it allows us to work out, okay, in 30 centimetres, which will result in a certain length of time based on how quickly we're travelling, we need to get the cutting head in this particular position. And so all that machine vision is happening on the actual robot, happening reasonably quickly, and moving the whole system in and out. Our original system, we had an electric actuator. This one's got a hydraulic actuator driving that 4-bar mechanism, moving it in and out. You can see also the hydraulic pipes, tubes there. We need a hydraulic cutting head just so that we can get enough torque on there to actually cut these things off. Now I've got another video showing an overhead view of it moving in and out. Now realistically, is it going to cut everything perfectly? Well, the answer is no. The idea is that it can cut about 90%, and then with that 90%, there might be a few that you need to walk along and do a quick clip, do a quick cleanup, but if it can do 90% of the work, well, we've got a time saving. What does that time saving look like? Well, having calculated the economic benefits of this, we've worked out how quickly we can cut, and we've got a direct comparison down the bottom there. So manual pruning only, and these are Stephen's figures, we've got a speed of about 80 metres per hour that can be achieved reasonably, reproducibly. So 30 hours per hectare, just over $1,100 per hectare, doing the maths there. This system, we've done some mechanical pre-pruning, so flying through quite quickly and cutting off some of the big branches that are a long way off the cordon, just so they don't get entangled in things. We're hoping further iterations of this will be able to automate some of that process. That's reasonably cost effective to do because we can travel quite quickly. Then the robotic pruning that travels at about half that speed. So we're going through about 3 hours per hectare there. And then a manual cleanup where we can travel through a lot faster than manual pruning, but a lot slower than the robotic pruning. And so we've got final figures there of about 50% of the cost. Now, that's a significant improvement in labour costs and in time, but we're hoping to improve that further. Now, I mentioned that we talk about how much the cutting head moves. If you look down the rows of these things, you think, they're pretty straight. But this is what our cutting head LiDAR tells us. This is the cutting head movement as it moves along, and you can see there's lots of areas where it's gone in and out, in and out, in and out. And this is happening dozens of times a second where it's deciding, do I need to extend that cutting head further a bit? Do I need to withdraw that cutting head a little bit? So I can track the cordon and get as close a cut as I can get. I mentioned we published a paper. That paper is freely available on the internet. If you search for tractor-mounted grapevine pruning system, you'll find it. It's open access paper, which means anyone can read it around the world, which people have been doing. I'll come to in a moment about that. But it brings us to our next steps. Where do we go from here? One of the things is some grant applications to improve this system further. And so we've got 2 applications at the moment. Some things have gone slightly over water, so we'll come back to those. But the question might be, what might need to be improved? Well, realistically, we've got a prototype, a working prototype, a prototype that's done 3 seasons now, and is doing quite well, but it's not a prototype that you can kind of sell on the open market quite yet. There's a few things that are a bit rough and ready about it that need some improvement, particularly improving our sensing a little bit, but more to do with the reliability and user interface. It's been working many, many hours though, so those things are going quite well. Our 2 grant applications, we've got one for an AEA Ignite grant and one for one of the Horde Innovation schemes. We're expecting to hear back in a few months' time for each of those. Hopefully they'll provide some more funding to actually take this next step further so that it could be provided to everyone that wants a system like this. But the other thing is, I mentioned people have been reading the paper, and, well, one of the people reading the paper was from Venice, or just outside Venice, 20 k's outside Venice, I think. And they've contacted DFA and myself, and we've got a meeting with them next week to talk about, they've said, well, we'd like to be the sole supplier in Italy about this. We want to talk more about the technology and how it works, your algorithms and things like that. Which was quite a surprise, quite a pleasant surprise. So we'll see how that goes, and hopefully in time we'll be able to report back on some positive innovations of some technology developed in Australia, in Victoria, being used in the region of Mildura, over in Venice. Something that we can brag about for many years to come, hopefully. Having said that though, it doesn't necessarily need to end there with winter pruning, because there's lots of other areas where there's potential other innovations that could be included. Might be other things around hyperspectral imaging, where we've got a high-end hyperspectral camera, and hyperspectral cameras allow us to see light not just in red, green and blue hues that we normally deal with, but other hues that our eyes normally can't detect. And you can do all sorts of detection of disease and plant health with those sort of things. IoT monitoring systems are all the rage, and Sunny Tafe's doing work in that sort of area. There might be specific things that you want to monitor within a farm or within an environment that might be something that we could use. It also might be something that you've got a particular idea that has bugged you as you sit on a tractor or walk through your farm, or you've just talked to people and people have said, if only someone could solve this particular problem, let me know where it is and we might be able to actually solve that one. There's my email there if you want to take any notes and note it down. It was at the start of the presentation as well. I'm sure Justin can send it to you. If this pops up in 3 days' time and you're like, I should have talked to him about that a few nights ago. But let me leave with some special thanks to people that have been involved in the project. There's been lots of you. If I've missed your name, I'm dreadfully sorry. But this hasn't been a success just because of myself. It's been many people providing input along the way, whether it be programming input, whether it be telling me, no, that won't work sort of input, whether it be trying it out on the farms, whether it be improving things along the way. Stephen's been doing a lot of that work.